Hello, everyone. You guys are still early. You can wait for another few minutes. Let us wait for a while more for your classmates to join us. Okay, maybe we should start now. The first question is quite straightforward. So while waiting for your other classmate, we can start doing one or two of the first question. So find the inverse Laplace transform of the following signals or systems. So you take a look at the questions. So in these chapters, I don't expect you, like I said earlier, I don't expect you to use the integrations to find out the inverse Laplace. So most of the time, 99% of the time, our inverse Laplace can be found from the table itself. So let us look at the first question. 1 over s plus 1. And then for our table, I have also written different ROC will have different answer, even though you have the same Laplace transform. You see, both are 1 over s, but because one is positive, one is negative, your answers of the inverse Laplace will be different. So now let us look at A, 1 over s plus 1. So immediately you found out that is here. So you should have e power to negative t ut if your real numbers of s is greater than negative a, in our case negative 1. So that is the answer directly. You can straight away write e negative, no longer at, it's just negative t and ut. And for the second part B is the other way. You see the region of convergence is lesser than negative 1. So it becomes this case. So in this case, very similar, but it's just a negative sign on e negative et u of negative t. So if I plot it out in graph, let's say this is 0, the first graph will look like this. This is e negative t, and it starts from time equals to t equals to 0. The second graph will be just a reflection of it. This is still t, but now the graph comes from negative infinity and ends at 0. The rest are all 0 here. All right, so this is negative e of minus t. So that's the difference between them when you have different regions of convergence. Then now you look at question C. Question C, s squared plus 4. Then you found this one. Okay, real part greater than 0 is correct as well. And then we know that this is s over s squared plus 2 squared. So if you do the inverse of it, you get cosine of 2t and then ut. All right, cosine of 2t and ut, meaning it looks like this. This is 0. It will start at 0 only. All right, the rest are all 0. It starts at time t equals to 0 because of the ut here. Now let us look at question D. This question D requires you to use frequency shifting. But then because in the table that I provided for you, I have also included frequency shifting over here. So you can just directly use the formula here. So what you need to do is that, again, this 4, it becomes 2 squared. So that it becomes exactly same as this formula. Then you will have the answer, the inverse Laplace equals to e negative t cosine of 2t, and then need to multiply by ut. All right, so if I require you to plot this signal, how do you plot this signal? First, let us try cosine of 2t. This is 0, right? So cosine of 2t will look like this. This is only for cosine of 2t. How about et, e negative t? E negative t start from 1 and then slowly go down to negative infinity. Slowly go down to 0 when time t is approaching infinity. So it means that our cosine graph is actually squished within this thing. All right, because it's a multiplication. So it's squished within the e negative t. And then our UT will tell us that the signal starts from 0 only. So anything before 0 is always 0. And then anything after 0, it follows the squish cosine curve, which is the red color curve here. All right, so I erase off the other nonsense curve, then you can see clearly how does the curve looks like. All right, so that is how it looks like. It's still a cosine wave, but this cosine wave, the amplitude is getting smaller and smaller because the amplitude is being suppressed by e power of negative t. All right, so it will look like this. So no question, I'll go to the next one. If you have any question, you can ask here or type in the chat. All right, the next question, if you see carefully, they are actually the same questions. 2s plus 4 divided by s squared plus 4s plus 3. This is also the same. This is also the same. The only difference is the regions of convergence. So what does it mean? So let us try to break this system down first, because like I said earlier, if you see a system with s squared, unless this is cosine or sine, but in this case it's not. So you need to break it down into using partial fractions to break it down into two subsystems. So what we can do is this 2s plus 4 divided by s squared plus 4s plus 3 is s plus 1 and s plus 3. So this is the very simple case. Then multiply everything by the denominator. We get this a of s plus 3 and b of s plus 1. So the next, we let s to be equals to negative 1, so that one side to be 0. So we have negative 2 plus 4 equals to a times 2. So this tells us that a is equals to negative 2 times plus 4 is 2, 2 divided by 2 is 1. Right, then we have another s equals to negative 3. We get negative 6 plus 4 equals to b minus 2. So b will be equals to, oh, it's still the same thing. It's still 1, right? Yeah, b equals to 1. So now it tells us that I can break down these systems. Hold on, let me let Humai enter. So now it tells us that I can break this system down by using partial fractions into 1 over s plus 1 plus 1 over s plus 3. Then I will need to do inverse Laplace for each of them. Okay, so if you look at this 1 over s plus a, there are two kinds of inverse Laplace. One inverse Laplace will give you the positive side. This one just now I have already tell you how does the graph looks like, right? It's starting from 0 and then the positive side. Starting from 0, go up and then go down. Then the other graph looks like the negative side. I draw it properly. This one's supposed to be all 0. Okay. So this is the difference between two of them. And the difference is at the regions of convergence. So you look at this one. This one is greater than 1. Meaning that if I have the inverse Laplace for both of them, this will be e negative a, or I just will write negative t ut, and the other one will be e negative 3t ut. And then my region of convergence will need to be real parts of s greater than negative 1, real part of s greater than negative 3. And if I combine these two, this is negative 3, this is negative 1, it must be greater than negative 1, it must be greater than negative 3. So it ends up to be here. So I just need real part of s to be greater than negative 1. Then I satisfy this equation. So you can conclude that the first answer is actually e negative t ut plus E negative 3t ut, because the region of convergence satisfied for both of them. Now, if you look at the second questions, the B, it must be less than negative 3. So if you look at here, if it's less than, then it should be negative number. Then now let us see if it's satisfied. If I have a negative number and negative t, negative number and negative t, my real part of S must be smaller than -1. Real part of S must be smaller than -3. So I have -3 here and I have -1 here. I must be smaller than -1, so it's here. Must be smaller than -3, so it's here. Then the overlap regions is real parts of S must be smaller than -3. So which is correct as well. So I can conclude that this answer is actually negative E minus t u negative t minus E minus 3t u negative t. All right, so for the second questions, for the part B, this is the answer. Now, if you look at part C is slightly different. Part C, I have two parts. If I draw the line chart first, I know definitely one is -1, and the left side must be -3 because it's smaller than -1. And then the conclusion is that it is in the middle, meaning that my region will be in the middle. The only way that can make it in the middle is that it must be smaller than -1. It must be greater than -3. Correct? Then only it can be in the middle. So we know that this one, the real part of S must be smaller than -1. And this one, the real part of S must be greater than -3. So if you find the inverse of it, smaller than -1, so the first part will be negative E, negative t, u negative t. The second part must be greater than -3. So it becomes a positive one. Positive 3t, u positive t. All right, so that is the answer for the third question. Okay, any problems here? No, then we go to the next one. Okay, now question 3. Inverse Laplace of this one. First, we need to do partial fraction to break this down. So let us try here. S squared plus 2s plus 5, and this is s plus 3, s plus 5 squared. So we can write it as a of s plus 3 plus b of s plus 5, because it's square here, so we have another term, c of s plus 5 squared. Then we multiply everything by the denominator. S squared plus 2s plus 5 equals to a s plus 5 squared plus b s plus 3 s plus 5 plus c s plus 3. Now the next step is choosing different s value. So let us choose s equals to -3. Then I can eliminate two of them. So this becomes 9 minus 6 plus 5. So I write here 9 minus 6 plus 5, because s is -3, equals to a of -3 plus 5 is 2. So this is 2 squared, so it's 4. So in this case, a gives us, let me take out my calculator. 9 minus 6 plus 5 is 8, divided by 4 to be 2. Right? A is 2 in this case. So the next one, let's s equals to -5. So we then have 25 minus 10 plus 5 equals to, this one be 0, this one be 0, only c left, c of negative 2. So this c will give us, let me use calculator, 25 minus 10 plus 5 divided by minus 2. So it gives us minus 10. All right, let me check again, my calculator. 25 minus 2 minus 25 minus 10 plus 5, 20 divided by, okay, correct. Okay, now we don't have any other s value that can eliminate either of them, so we just randomly put an s value. So I just put s equals to 0. So in this case, when s is equals to 0, we have 5 equals to 25a plus 15b plus 3c. All right, correct? 25a plus 15b plus 3c. But now we know what is the ABC already. So we substitute it into it. 25 times 2 plus, or we don't know what is b. So b is written here, plus 3 of negative 10. So in this case, what does b give us? Let me use a calculator. 5 plus 30 minus 50 divided by 15. So b is negative 1. Right, b is negative 1. So now we can make conclusion here. I should already write up here that the partial fraction actually gives us 2 minus 1 and minus 10. And then we can start to apply wherever we have on the table. So 2 over s plus 3 is here. And then we see our real s must be greater than negative 3. So this is correct. So we get 2e negative 3t ut. This is for the first part. Now for the second part is 1 over s plus 5. And in this case, because it's s plus 5, we know that our real s must be greater than negative 5, which real s greater than negative 3 also is always greater than negative 5. So it's satisfied as well. So here we can just use the same formula again, same tables again, e power to negative 5t ut. And the last one is s plus 5 squared, which is this case. And we know that the real side must be greater than negative 5 as well, which negative 3 also satisfies it. Because once it's greater than negative 3, it is always greater than negative 5. So this becomes minus 10t e negative 5t ut. So that's the final answer. All right, all these three added together. So 2e negative 3t, you can factorize the ut out since all the ut are the same. So it become, I write in blue color here, 2e negative 3t negative minus e negative 5t minus 10t e negative 5t, and then everything multiplied by ut. All right, you can also leave that as the final answer. It's more neat in this case. All right, so the next one is find the inverse Laplace of each of them. All right, for this one, you will need to do one extra steps. Before partial fraction, you also need to do one extra steps. That is because partial fractions, you can only apply on a fraction that has the numerator, that has denominator higher order than the numerator. Meaning what? You can only apply on fractions such as s plus 1, s squared plus 2s plus 3. You see, this one is power 1. This one is power 2. Your denominator power must always be greater than the numerator power. Then only you can apply partial fractions expansion. All right, partial fraction expansion, correct. So in this case, you look at this, power 1 and power 1. You cannot do that. So what you can do is that you can factorize it out first. So what do I mean by factorizing? You see 2s plus 1, s plus 2. Or another method, you can do long divisions. If you will learn long division next week also, but that I'll just tell you now first. It's quite useful. So it's like the way you do normal division, except that now everything has s inside. So now the first step you need to do is to ensure that your s become 2s. So how do you ensure that your s become 2s? You multiply by 2, correct? So when you multiply by 2, this becomes 2s plus 4. And then you have a remainder of negative 3 because it's 1 minus 4. So this one, you can write it as 2 minus 3 over s plus 2. Right? This is how you can do long division. Right? Anyone don't understand about this part, the long division part? Because I think I haven't taught long division before, but this is just kind of basic mathematics. If you don't understand, I can teach again. No, right? Okay, everyone fine with that? So you break this down into these two parts. 2 minus 3 over s plus 2. And now you don't even need to do any partial fraction for this question. Because 2 will give you 2 delta t. And this one will give you e negative 2t of ut. You must take care of this one, okay? So that it's positive one when it's greater than negative 2. So that's the answer for A. Let me erase off some space at the bottom. All right, now let us look at B. B is also the same thing. S squared plus 6s plus 7, s squared plus 3s plus 2. We need to do long division. S squared plus 6s plus 7 divide by s squared plus 3s plus 2. And in long division, you look at only the first term. No other terms, okay? You only look at the first term. All right. So the first term, to change s squared to s squared, is multiplied by 1. So you get s squared plus 3s plus 2. Then you minus off, you get 3s plus 5. And now you see you can't divide anymore because yours is s squared, but the remainder is only 3s. So that is the final answer already. 1 plus 3s plus 5 divided by s squared plus 3s plus 2. Right, so that is how you can do your long division to break this down. Now you need to do partial fraction expansion on this one. So this become 3s plus 5 of s plus 1, s plus 2 equals to a over s plus 1 plus b over s plus 2. 3s plus 5 equals to a over a divide plus multiplied by s plus 2 plus b multiplied by s plus 1. So when s equals to negative 1, I get 2 equals to a. When s equals to negative 2, I get minus 1 equals to minus b. So both are 1. So this is just, not both are 1. This is 2 over s plus 1 plus 1 over s plus 2. Now, okay, I continue writing from here. This equals to 1 plus, don't forget the 1 in front because you did a long division earlier. Ayo. Okay, luckily still here. S plus 1 plus 1 over s plus 2. Now we do individual inverse Laplace. 1 become delta t. 2 over s plus 1 become 2e negative t ut. S plus 2 become E negative 2t ut. All right, so that's the final answer. And it's positive ut because of this, because the region of convergence is greater than negative 1.
Sure.
Yes. Yes.
Sure.
Kinong, do you ask anything? I didn't hear you just now. Are you asking anything? If no, then continue. If you have anything, you can also write down, because just now I couldn't hear you. I hear you calling me only. Then now I see your microphone is muted. Okay, let us continue. All the other people, you all can hear me well, right? I assume you can hear me well. But can anyone just type on the chat? Okay, can. Thanks, Karthik. All right, so I'll continue to question C. So question C, let us clear the screen. Oh, Kinong can't hear me. But how about others? Besides Katil, how about others? Can anyone not hear me or hear me? Or I type here. Can hear, right?
I can hear you well.
Okay, good. So I think only Kinong has the problem. But I think he reconnecting already because he quit the chat room. Okay? I'll just wait for him to come back while we do the question 4. Okay, good. Thanks for responding, everyone. All right. Okay, Kinong is back. Hold on, let me let him in first. Hi, Kinong, can you hear me now? Can you hear me now, Kinong? All right, so now we go to question 3. Question 3, s cubed plus 2s squared plus 6 divided by s squared plus 3s. You guys hold on now. All right, mate, it's okay because later I will send this recording to those who cannot hear. Then you should be able to hear. All right.
Sorry, sir. I was in another lab just now.
Oh, okay.
That's why I was late.
No worries. You can watch the record because I recorded this now. So we are already in question 4. So 1, 2, 3, you can watch the record to get it.
Sir?
Yes.
Oh, okay. Thank God.
Oh, can hear already. Okay, good.
Yeah, sir. When I asked for question B, right? Because
Okay.
I did partial fraction, but I didn't do the division first. I just factorize out. So I didn't get a 1 plus.
Your answer will not be correct because partial fractions you can only do when your denominator is higher order than your numerator.
Oh, so I'll be like missing one answer there, right?
Not just missing one answer. I think your ABC will be also different.
No, it's the same. AB is the same. It's just that I miss out the 1 there.
Oh, really? Your AB is the same if you just
Yeah.
do partial fraction. Maybe
Yeah.
only for these questions then. Because yeah, I think this question just so happened that AB is the same. Yeah, because if you do partial fractions with both numerator and denominators, as in the power of denominator is not greater than numerator, then you will not get the right answer. Partial fraction can only be done when your denominator's power greater than the numerator's power.
Thanks, sir.
Okay, so now we look at C. So C, again, we do the long division first. S cubed plus 2s squared plus 6 divided by s squared plus 3s. And then now, like I said earlier, you want to change the first one to the first one here. So s squared, how do you change to s cubed? You multiply by s. All right, so when you multiply by s, you get s cubed plus 3s squared. So the remainder is negative s squared plus 6. So how do you change your s squared to negative s squared now? You multiply by -1. So when you multiply by -1, you get negative s squared. And, okay. Here I have some problem already. I actually missed out something here. I shouldn't write it this way. So although I know this is plus 6, but then in doing long division, it's best that you can write all the powers out. Meaning that this is power 0, this is power 1, this is power 2, and this is power 3. Then you will not get confused.
So is it 0s?
Yeah, so this is 0s. Okay, so this is just 0s. All right, so this is actually plus 0s. So this becomes negative s squared minus 3s. All right, and then the remainder will be, this is 6, 0 minus 3. So 0 minus negative 3. So this becomes positive 3s. So it's 3s plus 6. You cannot divide anymore because this one is power to 1 already. So this, you can expand it as s minus 1 plus 3s plus 6 divided by s squared plus 3s. All right, so this is after you get your, after you do your long division, you will get this answer. But this is not the end yet. I erase off the long division. You will still need to do partial fraction on this side. So let us try. 3s plus 6 divided by s plus 3 equals to a over s plus b over s plus 3. So 3s plus 6 equals to a s plus 3 plus bs. Then now s equals to 0, the easiest one. So you get 6 equals to 3a. Hold on, Brian is asking me to let him in. Wait, let me take attendance first. Brian is here. Jerry is here also. Okay, so Leo, Alan, and Edward is not here. Okay. All right. Okay, back to topics. So this one, I get a equals to 2. Then now I substitute another one. S equals to negative 3. So negative 3 becomes negative 9 plus 6 is 3 equals to negative 3b. So b will get negative 1. So this is actually s minus 1 plus 2 over s minus 1 over s plus 3.
So that one is negative 3, is it? Or it's a positive 3?
Okay. Oh, yeah, you're right. My mistake. This is negative 3. So b is positive 1. So this one is positive 1. Thank you for pointing out. Very sharp eye you have. All right, so s is negative 3. So we get negative 3 equals to negative 3b. So b is positive 1. So let me check again. S squared 2s plus 6 plus s, so it's 3s plus 6. Correct? Okay, this one is correct already. Now, you will need to do all the inverse Laplace. So if you refer to the table was at the previous slide. What is s? Oh, you don't have s here. Oh, this is a very good question. Why suddenly I have s over here? All right. So for s, this one I need to refer to the properties of Laplace transform. Let me open up my lecture slide. Give me 1 minute. Lecture slide L7. Okay, for this one, I will go back and check inverse Laplace of S because it doesn't appear in my tables for properties and for the table of Laplace transform. I'll check and I'll let you guys know, but we continue with others first. 1 will give you delta t. So this is negative, so it is something that we do know here. And then 2 over s will give you ut, correct? 1 over s is ut. So this one is 2 ut. And then 1 over s plus 3 will give you e power of negative 3t ut. All right, so that is the answer without knowing what is this. Okay, I will go back and check, and then I will write a solutions to show you guys in the group chat. Right now, because I'm sharing this screen, so it's very difficult for me to check out this one. All right, so the last question. Anyone have any questions on here, the ABC? No, then I'll go to the last one. So the last question, oh, this one I think we did it in the class. Right, find the overall transfer function Hs, meaning that I want you to find out one transfer functions that looks like this. Input is xt and output is yt. So how do we do it? First, we have to know that transfer functions, let's say this one is a transfer function. This is the output. This is the input. Okay, I'm writing on the FS1. The output is always equals to transfer function multiplied by the input. Right, so this is the definition of transfer function. Transfer function is output divided by input. So output equals to transfer function multiplied by input. So now we do it one by one. What is this E? E is xt plus rt. So if we do both in Laplace transform, everything is just changed to Laplace domain, that's all. Everything that has a bracket t will change to Laplace domain. So we write here, Es equals to xs plus rs. And what is this r? R is the output from G when y is the input. You see this y will come down here. So we have rs equals to gs multiplied by input, which is ys. Now we can actually form the simultaneous equation already. This one, the ES substitute on top and the RS substitute on top here. So we get a long equation, YS equals to FS multiplied by XS plus RS, but RS is this one, so I should really write RS is GS multiplied by YS. If I multiply everything, Fs XS plus Fs GS YS. Then now I pull the YS to the other side. So I get YS 1 plus, or 1 minus, because this is a pulling to the other side. 1 minus Fs GS equals to Fs XS. So now the transfer function Hs is defined as output Ys divided by input Xs. So I want to find out what is Ys divided by Xs. So you just pull Xs to the left side and pull whatever non-Ys to the other side. You get Fs divided by 1 minus Fs GS. So that's the final answer. Transfer function is just Fs divided by 1 minus Fs GS for this case. Right? It's a bit different from the one that you see in the lecture notes. The reason is that the one that you see in lecture notes is actually negative sign here. Now this is positive sign. So if it's negative sign, you will get Et equals to Xt minus Rt. And then later on, you will find out that your final answer actually is plus 1 plus Fs GS if it is a negative sign. All right, now this is positive sign, so your final answer is 1 minus Fs GS. All right, so I think that is all for the tutorial this week. Any questions on the tutorial? If no, I will go back and check out this one. How do we do Laplace transform for S? This particular one. I didn't even notice that the questions contain this one, so I didn't prepare this. Right, the rest, I know I can do it on the spot, so I will just do it on the spot. But this S is a bit tricky, right? You cannot really get the Laplace transform directly. So I'll go and figure it out. All right, no questions, then let me check. Okay, yeah, this is the last one. I have one announcement to make. Let me stop sharing. Is everyone here? Not everyone here yet, right? But it's okay. I'll also put the announcement on the WhatsApp group. All right, so that is the latest information I received from our program director. Is that the final will be released on week 12. Correct? This one you already know, right? Final will be released on week 12. The thing is that the program director also mentioned that it means that we need to finish teaching our lecture and tutorials by week 11. All right, so meanings that I have actually 3 weeks of lectures left for this module, but I only left with 2 weeks. So next week, I will be teaching 2 lectures at the same time. You guys okay with that? Okay, next week, let me check your schedule. Yours is Wednesday, 4 to 6 p.m. Eh? Oh yeah, okay, Kartik coming in. Okay, can. I didn't notice Kartik is waiting. Let me just write in the whiteboard, then everyone can see. All right, so today, this is today. Today is week 9. We have week 10, we have week 11. That's all. After week 12 onwards.
So week 12 onward cannot teach us.
According to our program director, he don't suggest us to teach on week 12 onwards. He wants us to finish the syllabus by this week.
But the last chapter is probabilities, right? So
yes.
Okay. Still okay.
So what I'm going to do here is that week 12 we can still do lab. But he says that there's no more lecture and tutorial allowed. All right, we can still do lab. So our lab, let me think, lab 1, 2, 3. Our lab 3 will be between this one and also the lab test. All right, between week 12 to week 14. All right, so no more lecture and no more tutorial here. Now, I tell you that I have 3 more lectures to go. So today is done already. So next week, lecture, so it's a Wednesday, 4 to 6. I will talk about lecture 9 and lecture 10. Both of them about Z transform. So means that you need to watch 2 videos. And then we will start at 4 p.m. on the Zoom lecture. Because if we don't start at 4 p.m., I don't think within 5 p.m. To 6 p.m. we can finish talking about 2 lectures. So you have to watch the Z transform video on your own before Wednesday. I have not done the Z transform second video yet, meaning the lecture 10 I have not done yet, but I will do it today. All right, so that you all can get it by end of today. Correct, you all will get it by end of today. So next week, Friday, again, we know that we are 2:30 to 4:30, right? Oh, wait, somebody check. Why do we stop at week 12? All right, because your exam question will be released on week 12. And then Dr. Aravind instruct all of us that we have to finish teaching by week 12. So that when you get the exam question, you know everything about the modules already. Okay, so any more question about this one? I think all your other modules will be similar because this is the instruction given to all the lecturers, not just me. All right, but maybe because today only we get the information, so maybe I'm the first one who tell you that. All right, so exam questions will be released on week 12, early week 12. I think day 1 of week 12, Monday of week 12 or something. To be more exact, 29 June. I'm not sure 29 June, is it Monday? You all can go and check. So on Friday, we will have tutorial 9 and tutorial 10. Both are on Z transform. Then on week 11, Wednesday, 4 to 6, we will just have lecture 11. This is the last one already on probability. And this probability is very simple one. It's a very fundamental probability. Quite awkward to be put in this module actually. Then 2:30, we'll do the tutorial 11, which is on probability. Then you finish everything. So week 12, week 13, week 14, I will find 2 of the week to do these 2.
So why don't we just you don't have to lecture us about the probabilities. You just push the Z transform into week 10, week 11. Probability we just go through the video ourselves, and then we do the tutorial only.
Well, but Kin Long say no. So I think it's better that
So the probabilities don't have like permutation or combination, all those things, right?
yeah, don't have.
Then
So it's
it
just
should be
like
okay.
more of statistic rather than probability. It's a statistics. But then it's okay. I think this is fine because we have 2 hours, 2 hours. Or else, if you want, I can shift this to here. Shift this to here. Meaning that week 10, next week, we'll just do lecture 9. Can? Okay. So Kin Long also think this is good, right? So week 9, week 10, we will just do, okay, let me erase this. So we can rewrite again. All right. Okay, how do I get back to drawing? Okay, so this one is 4 to 6. All right, next week will be on lecture 9 and tutorial 9, just as usual. Then week 11 will have lecture 9 plus lecture 10, probability. This one very fast one. It's a short topic on probability. Tutorial 9 plus tutorial 10.
So,
Right? Yes.
or maybe we can make like lecture 10 on next week as well, but then we talk half about it.
So this one plus half
Yeah.
of lecture 10.
Yeah. So lecture 10 and probability will be on week
tutorial
11.
10.
Yeah. Tutorial should be fine. I think you can put on week 11 because we need to fully study the Z transform too. Only we can do the tutorial for it, right?
Yes, correct. You are right. Let me take the eraser. Now everything becomes so complicated. Okay, I can talk about half of the lecture 10 on next week. All right, we can talk half the lecture 10 on next week so that on week 11 we have more time to talk about another half. I think this is a good suggestion. And then okay, that's all. If I'm not mistaken, all your other modules will be squeezing everything by week 11 because instructions given to us is like this. So
yes. GG, man, one of my modules still got 3 topics left.
What are the modules? What is the modules?
Integrated electronics. We still got like 3 topics left.
Who is the lecturer for that? Integrated electronics.
Dr. Chu.
Dr. Chu, okay. Oh. This one also have 3 topics left. Actually, Z transform 1, Z transform 2.
But from the syllabus, you need like 15 hours.
Okay. Just now, Kin Long, you want to ask some question? Is it? I heard your voice just now.
Yes, sir. I want to ask because initially you planned the lab 3 on week 11. So you are going to push it until week 12 now, is it?
If you guys agree with it, I can push it to week 12. Okay, another things I want to let you know is that week 11 and week 12, week 12 and week 13, I forgot which of the week, Dr. Aravin has planned some lecture for you guys, for all EE students.
What kind of lecture?
Guest lecture, something like that.
Guest lecture about signal.
He will invite professors from other universities to talk, give a webinar basically. So I'm not sure.
Like seminar.
Yeah, seminars. Yeah, and all EE students, everyone EE student have to attend that. Even lecturer, you will see me in the class as well. I have to attend that as well.
Sir, you are saying that all Intex EE students are only us,
All E student, all E student. This is across
Maybe-
the whole program.
which means other Intex EE students will be joining as well.
Yes, correct. So it'll be like 50 or 60 people in one webinar.
Only year 2 students or year
all
1
of
to year
them,
4?
all of them, year 1, 2, 3, 4.
Wow.
Wow. What is the topic about?
Oh, this one I'm not sure. I don't know yet. This is just what I know the information from program director. That's all.
Very vague.
No, he invited some of the professors or lecturers from other university to talk.
Okay. Let's see whether, I don't know, whether.
Sir, so I just want to confirm lab 3 and lab test now.
Okay.
When will be the week that we are doing it?
Let
Which
me
week?
check my schedule.
Because initially you were saying that lab test will be on week 14, right?
Yes, lab test definitely will be on week 14. This on week 14. We don't need to change this already. Because I put all my module lab tests on week 14. So this one, I think I can let you guys choose. You want to do in week 11 or week 12? Only 2 of them can choose because I don't want it to be week 13 or not very close to week 14. Either 11 or 12. But the lab, even if you do on week 11, I'll give you 1.5 weeks to, just as usual, 1.5 weeks to do. So it's actually after week 11 only you need to do. So we will discuss, why not just make it to week 12 lah? We make it to week 12. Then week 12, I got more time to discuss with you on the lab 3. Okay?
Oh.
So we put lab 3 on week 12. So meaning that you need to submit your lab report by Sunday of week 14. 1.5 weeks or so.
Sir, I'm just proposing that can we discuss lab 3 on maybe week 11 tutorial time on Friday?
I'm not sure whether we got time or not because
yeah, I'm just proposing. So if we have time, can we do that?
Okay.
Because
if
we can have more time to work on it.
Okay, can. But then I will still stick to on week 4 Sunday to hand in lah.
Week
I mean week 14
Sunday. Oh,
week
week
14 Sunday.
There's lab 3 or lab test?
Lab 3. Lab test is on the spot. Lab test, I'll give you just 1 hour to do. And then 1 hour you need to submit it already. It's
So
it's the test. It's not a lab. Yeah.
Lab 3 will be on, submission will be on week 13 Sunday, is it?
I confused with the weeks already. I'll just give you 1.5 weeks. From whatever day that if I discuss here, I'll give you 1.5 weeks here.
So week 12 Sunday lah. Assume it to be more or less there.
Okay lah. I consider Sunday as the first day of the week, so it's week 13 Sunday.
Oh, okay.
Okay. Because there's a confusion because you talk about week 12 Sunday because you talk about end of week 12, right? When I say Sunday, it's beginning of the week, so it's beginning of week 13.
Okay. Sunday is the beginning of.
Yeah. Sunday is the first day of the week. You all should know that, right?
No, sir. In my opinion, Monday is the first day.
No. You go and Google. When I Google for you now. Yes.
Sorry,
sir. No need Google.
Sorry for disturb.
Yes.
If we discuss on week 11 Friday, then the submission on the next week Sunday is kind of rushed. We have only 8 days. So are you mean that is on week 14 Monday?
Okay, can also. On Monday can. I'm okay with that. As in week 14 Monday, not week 14 Monday.
Sorry, week 14 Sunday.
Week 14 Sunday, then it's a bit too long already. Then it's more than 2 weeks already, right?
Because we are just discussing that it probably on week 11.
Okay.
It might be on week 12 also.
Okay. Week 14 Sunday submit.
Yeah.
Okay, can. So meaning that our slot officially is still on week 12 lah. Officially. Just that maybe we'll discuss early.
Yeah.
Okay, can. This one can.
Okay.
Wow. This one is like negotiations. Okay. Can nobody has any other problems? Any other questions on this one? If not, then we'll stick to this schedule. Although I think it looks very messy now. But I'll write down properly before each week to let you know what you need to do for each week.
Yeah, mainly the lab.
The lab only lab 3 left, right? Because lab 2 you should be doing halfway now already.
Yeah.
So it's not a big deal lah. Lab is an easy one to me, I think. Others, the lecture and tutorial is a difficult one. Okay, so if nothing, then that's all for our lecture tutorial today. Any more questions? No, then you all can take a leave already. Thank you so much. Hey, you all can leave already.
So the case study, will you be briefing us about the case study, or will you be like releasing on times only?
It will be releasing to you only. I will not, because we are not allowed to talk about the case study. So it's like really like final, like treat it as like you are doing final. When you receive the paper, you have to do it on your own.
Which means the paper is something that we actually can understand, right? It's not like something like out of the content or all this.
Okay. It is not exactly everything you learn in this module. You will need to do a little bit of research from the internet, but it's related to signal and systems. But of course, you can understand the questions. Just that to answer it, you might need to search internet for certain solutions. Okay, lecture notes might not be enough for that.
So what if the question is ambiguous, like we don't really understand certain part? Can we ask you for clarification, not for
For clarification, yes, can. Just let's say you don't understand whether I want you to explain or I want you to give example. Then I can tell you whether it's explain or give example. But this is you just think of this case study is something like when you submit, it's something like a report style. It's not like answering questions. You don't have to answer exactly what I ask. You are doing a report on that. So the question is very open. Something like, or ask you to research on this one and tell us the difference between these two and these two. Something like that. Then you need to research from the internet, and then you can write a piece of essay or whatever about what is the difference between them. You can also give example. The more detail you put in, then it's better. You can refer to the rubric. I will give you the rubric as well.
It's some sort. It's like we doing the lab report lah, or more or less something like that, right?
Yeah, something like that. Something like that. But so it's not on MATLAB lah. It's on general signal and system knowledge lah.
We can insert the picture or others also, right? Figures, tables.
Can. If you want, can. No problem. Not just words only. But it's not compulsory lah. But for certain thing, I will ask you to sketch something. I'm not sure whether your one got sketching or not, because I got so many more. I got 3 modules. There are one of the modules I actually asked them to sketch something. I forget, is it yours module already? Yeah.
Okay.
Then you need to sketch.
Okay.
Brian, you asked about intro, right? You don't have to write like a lab report. You don't have to write introductions, conclusion, all this don't have to. So maybe it'll be like a few case study. You just write case 1 and then you answer like an essay question. You want to break it down into maybe section or subsection also okay. As long as you answer whatever I ask there. Let's say I say evaluate certain thing. Then you can evaluate for a few points, and then each point you make it a subsection or a section. I'm fine with that also. Okay, anyone has any other question? No, then okay, I'll see you guys next week.